All right, guys, so what we're looking at today is inverse matrices and solving systems of equations using inverses. Now, the first thing we need to know when we're talking about inverse is the identity matrix. Now, the identity matrix is a matrix with a diagonal of ones and everything else is 0. This right here would be a 2 by 2 identity matrix. Now, we could also have a 3 by 3 identity matrix, which would look something like this, where we still have a diagonal of ones and everything else is 0. This will be the identity matrix. Something else that's interesting with the identity matrix is if we multiply it with another matrix on the right or the left, we'll still get back the original matrix we had. Multiplying by the identity matrix is the same as just multiplying by 1. It's not going to change the matrix itself. We'll get the matrix back. Any questions on the identity matrix so far? Now, something that's interesting with the identity matrix is that if we multiply two matrices together and get the identity matrix, it means that the two matrices are inverses of each other. So for A and B to be inverses, we need that A times B is going to equal our identity matrix. Because if the two matrices multiplied together give us the identity, it means that they are inverses of each other. So well, to check that, because we want to determine if these pair of matrices are inverses, we can just multiply them together. Now at this point here, we can do the multiplication, our over and down property. So we would go over and down. And when we do this, we'll have -4 times 1/4 plus 2 times 1/2. Now we can do it again and go over and down. And if we do this, we'll have -4 times -1/2 plus 2 times -1. We can do the same thing with the denominator. We can go over and, well, not denominator, the bottom row's matrix, and have -2 times plus 1 times 1/2. And lastly, we can go over and down, which would give -2 times -1/2 plus 1 times -1. Any questions on this here? Now we can simplify these and multiply, so we can do our -4 times 1/4 would be 1, 2 plus times 1/2 is plus 1. Our next one, -4 times -1/2 would be +2. 2 times -1 would be -2. 2 times 1/4 would be -1/2, and 1 times 1/2 would be plus 1/2. And last but not least, we'll have -2 times -1/2, which would be 1, and 1 times -1 is -1. And if we combine these here, what would we end up getting? And then, so are these two inverses? No. Because what are we looking for? We're looking for the identity matrix. So this here, well, really we needed that. These two zeros here needed to be what? Ones. Because if they were ones, then it would be the identity matrix, and these would be inverses. But since it's not, these are not inverses. Not inverses. No, they're not inverses of each other. Yeah, because we can do multiplication in the calculator. Do we want to check B or 1? We'll do this one here. We can do this one here in the calculator. So if we pull the calculator up, well, the first thing we need to do is make a matrix and go over to edit. And this is going to be a 2 by 2. So we would have 3, -5, -2, and 6. Once we get that typed in, we can go second matrix, edit B, which is a 2 by 2. Now we can do the fractions. We could say 3 divided by 4, or we can say alpha y equals enter 3 over 4. And then we have -1 alpha y equals enter 6. We have 1 alpha y equals enter 3. -2 alpha y equals enter 3. So we could do the alpha y equals enter and then type the number in, or we can type the numerator in, then do alpha y equals enter, and it'll still set it up the same. Any questions on this here? Now that we have both typed in, we can go second, quit, and we want to multiply the two together, yes?
I have a question. Which one are we doing? Because I think you mixed it again.
I did?
He didn't? Because I think he done the first one of this.
So he's going to do 1, but we did B.
Yep.
Yeah, that's B.
Okay, yes, thank you. Because that would have gotten us the wrong thing. 4, -1.
Wait, I typed in the fractions of B.
No, we typed in the first part of B and the fractions of
1, yep. Yep, so that is 1 second matrix. Go over to edit, and we can look at B. Matrix B, which would be our 3/4, -1/6, 1/3, and -2/3. Okay.
Wait, why is it 3 over 4?
It should be 1/3.
So we're doing 1, right?
We're doing 1, yes.
Crap, I just got B figured out.
What'd you get for B?
B is inverse.
So B would be inverse. Why did I switch it to 1? 4. Equals 3. Okay. Yep. So did y'all, were all able to get the ones for 1 typed in correctly? Yes. Okay. So if we want to check this, well, we'll plug the 2 in, hopefully correctly, and multiply them together. So we can set them right next to each other and multiply and see, do we get the identity matrix?
1 for 4.
Yes. B and 1 are both inverses. Now, I want to try something. Second matrix B, second matrix A. Because when we talked about multiplication before, if we flipped it, we got something completely different, yes? Not with this. Because if 2 matrices are inverses, the order in which we multiply them doesn't matter. We're still going to get to the identity. We're still going to get to the identity matrix. So this here would be yes. And the one before it would be yes as well. Any questions on this here? Now we're going to find the inverse. Given a matrix A, which has elements A, B, C, D. A inverse is going to be 1 over the determinant, AD minus BC, times the matrix D, negative B, negative C, and A. If matrix A is invertible, then A inverse is going to be 1 over the determinant of A. For it's a 2 by 2, so it would be AD minus BC, our cross method, times the matrix. Well, inside the matrix, we switched A and D, the numbers for A and D, and we made B and C negative. We switched the signs. So when we look at this here, if we wanted to find P inverse following this method, we would have 1 over the determinant. Well, that would be 7 times negative 1 minus negative 5 times 2. Now inside our matrix, our first number would not be 7, it would be negative 1. Our top left number would be negative 1, and the bottom right number would be 7, because those two numbers flip. Negative 5 and 2, well, we switch the signs. So in the places for C and D, the signs would, C and B, the signs would change, A and D switch. Questions on this here? Well, here we can simplify the determinant. 7 times negative 1 would be negative 7. Negative 5 times 2 is negative 10. Well, negative and negative do make a positive. Well, negative 7 plus 10 is almost positive 3. So we get to this here, yes? Now we just need to multiply everything in the matrix by 1/3. So 1/3 times negative 1 is negative 1/3. 1/3 times 5 is 5/3. 1/3 times negative 2 is negative. And lastly, 1 times 7 is, so this here is P inverse. And if we multiplied P inverse and P together, we would get the identity matrix. Any questions on any of this here? Bless you. We good with this here? Yes? Why don't we try this in the calculator? Neither here nor there. Actually, let's do this one by hand. We'll do the next one in the calculator. Now, for this one here, we're going to have 1 over the determinant times our matrix. So the determinant would be negative 8 times 9 minus negative 6 times 12. Our numbers inside the matrix would be as the 9 and negative 8 switch places, the 6 and negative 6 and 12, the sign changed on both of them, giving us positive 6 and negative 12. So let's figure out, let's simplify the determinant. Negative 8 times 9 is negative 72, yes. Minus 6 times 12 is negative. Well, the negative and negative would make a. Oh, wait a minute. Can we have 1 over 0? So this is not possible. Or we can say it is not invertible. It does not have an inverse. Because if we look back at the key concept for this here, because it says A inverse is equal to 1 over the determinant times our matrix, where AD minus BC is what? Not 0. Because if it's 0, it's really telling us that there's no inverse for this matrix. That's why I wanted to do this one by hand, because it would have just thrown an error in the calculator. But why? It's because the determinant is 0. Well, wait a minute. That means any matrix, if I want to figure out if it does have an inverse, I can just take its determinant. Because if the determinant is 0, it doesn't have an inverse. If it's not 0, then it does. So we could look at this one here and just say what? 3 times minus and solve. Is. So this would have an inverse. Now we can use the calculator to find said inverse. So the first thing we need to do is type it into the calculator. So we can go second matrix A, which is a 2 by 2. We would have 3, 7, 1, negative 4 would be our matrix, yes? Second matrix A. Now, how have we been writing inverse? Because there's been something that we've been using for inverse, the notation. Because how are we denoting A and A inverse differently? Because there's one small thing. The power of negative 1, yes? Do I have that kind of key on here? Well, it's the button we've been using for matrices. Well, these are ugly decimals, yes? Can we turn them to fractions? By doing math, enter, enter. Because what did we find out the determinant was? Negative 19. And in our formula, we have 1 over the determinant. So each one of these numbers would be over 19. There's not really any good numbers that reduce with 19. So we're going to most likely get some ugly decimals. So that right there is the inverse of our matrix. Questions on this here? We ready for the last thing we're going to cover? Solving equations with inverse matrices. Solving equations with inverse matrices. Now what we're going to do to write this is we're going to set up matrix A as the coefficients, the numbers in front of the variables. Then we're going to set the second matrix as the variables themselves. Because when we multiply, we go over and down. And if I did that, I would have 1 times x plus 2 times, what's the top equation? X plus 2y. The bottom one, 3 and negative 6, if we went over and down, it would be 3 times x plus negative 6 times y, 3x minus 6y. And then we'll set it equal to the matrix. Here it's 9, 3. We set it's equal to. But doing this here, and we can define it by A, X, and B, is really we're rewriting it as matrix A times our variable equation is equal to B, what it's equal to, yes? Now, if I multiply matrix A by A inverse, these here become the identity matrix. Yes? Because if two matrices are inverses of each other, when they're multiplied together, we get the identity. That's how we know that they are inverses. And as we saw at the beginning, if we multiply something by the identity, it doesn't really change it. It's like multiplying by 1. So really what I'm left here with is x, y. Well, what we do to one side, we have to do to the other. Now, start with matrix multiplication. If we multiply something on the left and the right, we get something different depending on what the matrix is. The only way we get the same thing is if they are inverses, yes? So what side did I multiply matrix A on with its inverse? The left. So when I multiply it on the other side, I have to multiply by the left, which will really tell us A inverse of B. So our answer is really just going to be A inverse times B, whatever that is. Now, this part here is really just that explanation just worked out. So, let's do that here. So the first thing I want to do is I want to write my matrices. Now the middle one is going to be our xy. Now the first matrix is going to be the coefficients. So we would have 2, and the other matrix would be what? Now we can call this matrix A and we can call this matrix B. Now to really simplify this like we did in that other one, well, we're going to multiply both sides by A inverse, because we know that A inverse times A here would become the identity matrix and really just simplify to the matrix xy. This here is going to be equal to A inverse times B. Now if we wanted to do this by hand, we could use the inverse equation that we found to find the inverse of matrix A and then multiply it by matrix B, or, well, we can grab the calculator and go second, well, okay. Second matrix, go over to edit A, which is a 2 by 2. We'd have -7, 2, 6, and 6 would be matrix A, is what we've defined it as. We can go second matrix, go over and edit matrix B. Matrix B is going to be a what? A 2 by 1. And this here would be 15 and 0. So the first thing we'll need to call up is matrix A. Then what would we hit next? We want our inverse and to the -1, and then second matrix B, enter. So we get -2, 2. So if we come back here, really what we're seeing is that the matrix xy is equal to -2, 2, yes? So what's the value of x? The value of y is? Because if we did this with 3 variables, it would have given us x, y, z. Any other questions on any of this here? Do we need to see another example with solving? We feel good with these here? Now, let's see here. I want to show you all, this is above and beyond. There's another way to actually find the inverse for this here. This one does have an inverse. Now, when we find the inverse, we multiply the matrix and its inverse, we get what? What kind of matrix? The identity, right? So the other way to find the inverse is this here, is we'll set this up. Now, on the left side, we have the matrix. On the right side, we have the identity, yes? Now, there's something called row augmentations. We can manipulate the rows themselves by adding, subtracting, multiplying, and multiplying by fractions is going to be dividing. And what the goal is to get this side here to be the identity, to be 1, 0, 0, 1. Once we get it there, the right-hand side is now the inverse. What ends up happening on this side will be the inverse. Okay? Now, some of the steps that we would do to get this here would be row 2 minus 2 times row 1. So row 2, if I multiplied 2 and 1 by 2, I would have what? 4 and 2, yes? Sorry, not subtract, we would add, because I want 4 plus 4 is 0. 2 plus 3 is 5. Now on top, we would still have 2, 1, 1, 0. Now what did I do? I multiplied the top row by 2 and added it to the bottom, yes? Well, over here, 2 times 1 would give me 2. And I would have 0, yes? And I'm going to add it to the bottom one. So 0 plus 2 is, and then we would have 1. So we're almost done there. Now the bottom row, I need this 5 to be a 1, yes? So what I'm going to do is I'm going to multiply row 2 by 1/5. So give us 2, 1, 1, 0. Here we're going to have 0, 1, because 5 times 1/5 is 1. Over here we're going to have 2/5 and 1/5. Well, I still don't have the top row correct because it's 2, 1. I want 1, 0. So what we can do is take row 1 and subtract from it row 2. So we'd have 2, 0, 0, 1. 1 minus 2/5 would be negative. 0 minus 1/5 is negative 1/5. 2/5, 1/5. Well, we're almost there, yes? We just need to multiply 1 by 1/2, which would give us 1, 0, 0, 1. Now, if we multiply by 1/2, we would have negative 3/10, negative 1/10, 2/5, 1/5. And that there would be the inverse matrix. And this here realistically is the way to do anything above a 2 by 2. So if you had to find the inverse of a 3 by 3, we have to do this here to be able to find it. And hopefully, it actually is invertible. It actually does have an inverse. Otherwise, you're wasting your time trying to get there. But this here is the end of chapter 4 that we're going to cover. You do have one more worksheet. That you're going to do here. So you don't have to do these by hand. because you can do them in the calculator, and you definitely don't have to do it by that method.